Alrighty, hi everyone, and welcome to the offline video on testing. This is sort of part 2. We already had a live video where we covered everything from slide 1 to slide 10. I'll be going through all of this again, but feel free to skip if need be if you've already gone through the live class. And just focus on the last 3 bits. Else, we can go from top to bottom as well. I'll take it slow, but at the same time, there's another video which covers everything from 1 to 10 more deeply. Before we start, let me give a context of what testing means. Testing in the real world basically means whenever you have a .js file or a .ts file or even a .java file, .golang file, which is supposed to do something. For example, you might write some express code in here, const app equal to express app.get slash something like this. You might write this code, and given this code is written, testing means you write another file that might look like something like this, index.test.js, which actually hits this endpoint and validates the response. The code over here might look like this: function test axios.get const response equal to await this. And then lastly, you can check, okay, is rest.data.username equal to whatever your expected value is, let's say Kirat. Then everything is fine. You can log test passed, else you can say test failed. Basically, if you write a lot of these tests, a lot of these files that actually hit your HTTP server and try to, validate the response given some inputs, is what's called a test. Here you could log something like test failed. So that is what testing lets you do. Only you don't do it in such a crude way. Given this is your code, you don't write functions and call them and then finally run node index.test.js. There are some frameworks that make it very easy for you to test, and you usually use those frameworks. A few common ones in JavaScript include Jest, Mocha, and VTest. We'll be focusing on Jest and VTest for this one, but you can pretty much choose any testing framework of yours. What does a testing framework let you do? It makes sure you don't have to write all of this logic of validation. It gives you some constructs to very nicely print all of your tests, very nicely find all of your tests. You might have 20 different test files. So a framework makes it easy, gives you some constructs here, use them to write all of the logic rather than writing such crude logic. You can do this as well, but no one uses this, no one does this. Everyone uses a testing framework to finally test your whatever application. In this case, this is a backend, but it could be a simple CLI, command line interface. It could be a game or the backend of a game. It could be a WebSocket server. Whatever you want to test, you use a testing framework for it. Let's get into understanding how you use one of these testing frameworks. Let's start by testing a simple Node.js application. We have written all of this code in the live as well. All of this final code is present here on 100xdevs code 2 / wait for it. It's probably here in the first slide as well. There you go. So you can find it in the first slide, 100xdevs code 2 / week 24 testing. It starts from writing a very simple test and slowly we build up to writing more complex tests. So if you want, you can write this code with me from scratch, or you can just clone this repository and start to look at, okay, the first slide wrote this code and then the second slide wrote this code, so on and so forth, whatever you're comfortable with. I'm going to write everything from scratch. Let me open Visual Studio Code. Let me create a fresh folder here, call it week 24 or 25, I think, testing part 2, or maybe offline. Let me open this in Visual Studio Code. As you can see, it is an empty folder right now. I will slowly add all the assignments, all the tests, all the small applications that we'll be testing. The first one, I'm just going to call it 1-easy. And inside this, I'm going to now, number 1, create a very simple Node.js application. Number 2, write some tests for it. So if I go to 1-easy, I hope by now we know how to bootstrap a TypeScript project. Let me do that really quickly. All the instructions are in the slide, but I'm assuming by now you know how to create a package.json, create a tsconfig.json, change the root dir to be /src, change the out dir to be /dist, and then add a source /index.ts file. Here we'll be writing some basic JavaScript code. Specifically, the function that we'll be writing today would be a sum function. It takes two inputs a and b, which are both numbers, and then returns the sum of the functions, a plus b. By the looking at it, you can yourself tell that this function does what it's supposed to do. There is nothing wrong in it. But how do you test it? You might say, Kirat, I will test it like this: const test 1 equal to sum 1, 2, and then console.log, or something like this maybe. If test1 equal to 3, then console.log test passed, else test failed. You could write code like this and do a tsc-b to compile the code. As soon as you compile it, you see a dist/index.js file which has all of your code in JavaScript, and then you can run node dist/index.js. It says test passed. Hopefully everything is good and your tests are working. But as I said, this is a crude way to write it. You usually use a framework like Jest or Mocha or VTest to actually write your tests. Let's see how do you initialize Jest in a TypeScript project. Here I'll have to go back to the slides because even I don't remember all the dependencies that you have to bring in. You have to bring in ts-jest as well as @jest/globals. If I install these dependencies and then run the command npx ts-jest config :init, which is similar to this command right here. This command initializes a tsconfig.json. It creates a file here called tsconfig.json. The command that we are running now, which is npx ts-jest config :init, creates another file called jest.config.js where all of your Jest configuration is. What is Jest? It is a testing framework. Whenever you're initializing the testing framework, you create a config file. This has some default values here. We don't have to touch this file for a long time, so just leave it as is. And now you can begin to write your tests. Generally, it's good practice to create a tests folder. You don't have to. Anywhere you can create a index.test.ts or whatever you want to call it. As long as it ends with .test.ts, it should be fine. It can be called sum.test.ts as well. You can name it whatever you want. Over here, we will first import the sum function from /index because here I am in the test folder. /index means this file right here, which was exporting the sum function. Notice we had to export it. Whenever you write tests, you have to now start to export your functions because there will be a test file importing them. So you will see this later as well when we reach the Express server. Now I will try to create my very first test. The way to write tests in Jest, and in fact most testing libraries, looks something like this. You have to import something called describe and it from the testing library. Eventually we will see we will replace this with VTest as well. That also exports describe and it. What are describe and it? They are a way to structure your tests. You could totally write, a bunch of functions here. Okay, test1, and then, write your test here, or test2, write your test there. But general practice, a good structure to follow is you create a top level describe. What does a top level describe mean? It means the very first thing that you put here is a describe function, which takes two arguments. What are you testing in this specific describe block? A describe block is supposed to add a bunch of test cases. You don't add one test case here. You add multiple test cases. So I say I'm going to test all of my sum functionality in this describe block. And inside this, each individual test case can be written inside a it statement. Should be able to add two positive numbers. Let's say this is the test that I'm writing. You usually write tests that cover a bunch of use cases. For example, what if sum works for positive numbers but doesn't work for negative numbers? What if sum doesn't work for two zeros if you try to add two zeros? So you try to cover as many edge cases as possible over here. So the first test that I'm writing is I'm testing whether or not the sum function is doing the right thing for two positive numbers. So what will I do? I will first calculate the sum, answer equal to sum of, let's say, 2, 3. And then I will say expect, and expect also comes from where? At jest/globals. Expects answer to be 5. Gives me an error here because expect answer dot to be 5. That is how you write a single test. I have not written this. I could totally write this, na, ke, const answer equal to sum function test1, and then over here do a if answer is equal to 5, then log test passed, else log test failed. So I could do this. This is also one way to write a crude test. But what is the equivalent in TypeScript/JavaScript testing frameworks? It is have a top level describe. Inside this, add all of your test cases for that specific functionality. We are testing the sum function. So I'm going to add multiple test cases here. Okay, yeah, this finds the sum of two positive numbers. This one can add the sum of two negative numbers and ensure that also works. And then I can add another test case over here for two zeros maybe, because that is also an edge case. What if my sum function doesn't work if I give it two zeros as an input? So all of these edge cases you try to cover in your test so that you have everything covered, and it's not like this specific test case was able to pass, but all the other ones failed. So you try to add as much coverage as possible. What does coverage mean? It means you try to cover as much of your code as possible. Now this is a very simple code, which is why even this much test covers everything in here. There's just one line of code. If you go through the very first test, it will call the sum function and that line of code will run. So in this case, you don't worry about, I'm not adding the new tests to improve coverage. I'm adding the new tests to improve the various edge cases that can come. Now the last thing is, how can you actually test? You have written the test cases. How do you run the test cases? And the answer is, if you're using Jest as the framework, you can go to package.json and you will by default see a test script here. Whenever you do npm init-y, a test script comes. If you try to run it right now, it'll say error, no tests specified. This is the default thing that JavaScript puts there. Here, if someone has initialized a repository, by default, just say that no tests have been specified. But what do we want? We want tests to actually run. We want the index.ts file is called. The Jest framework understands that this is test number 1, this is test number 2, and it actually runs the test. And hence, to do that, you can replace the test script with Jest. If you run npm run test now, you will see it starts to run your tests. It says tests have passed, 3 check marks over here. You're good to go. All 3 of your tests have succeeded. What if I change one of these tests to be like, Naya, expect 6 over here? Then the first test will begin to fail. As you can see, first one failed, other 2 succeeded. What if another developer comes and makes a mistake in my code base? They replace this with minus. Then can our tests catch this case? This is wrong now. But developers are dumb. Sometimes they check in bad code. So the thing that will prevent this bad code from checking in would be the tests that we have written. As you can see, still one test was able to succeed because 0 minus 0 and 0 plus 0 amount to the same thing. But the other 2 tests have failed. This is good. That is why you add multiple tests. If I had just a single test, it wouldn't have failed even though the code is not doing the right thing. And hence you add multiple tests and try to cover as many use cases as possible. So what have we learned? Okay, given a very simple function, no Express application, no WebSocket servers, simple function, how can you test it? You can create an index.test.ts file where you can add a top level describe with multiple test cases. If in the future you implement a multiply function as well. Then you will have to import the multiply function in the tests, as well as create a separate describe block for it. Can you put more test cases here just for multiplication as well? You can, but for better structuring, you will say, this has all my sum tests and this has all my multiplication tests. Should be able to multiply two positive numbers, something like this. There you go. Let me fix the test as well. And now if I run npm run test, it will run two things. It will run these test cases. It will also run these test cases, or just a single one that we have right now. Npm run test. It says one failed because multiply isn't doing what it's supposed to do. So can you see how tests help us figure out what's wrong in our code base? Now if I fix the test and run npm run test, it says all of your tests are passing. I can add more tests to the second describe block if I want. Right now I just have 3 tests over here and 1 test over here. If needed, I can add more tests here. I can also structure it better. I can have a separate file called sum.test.ts where I have the sum describe block. I can have another file called multiply.test.ts where I have the multiply block. And if I run npm run test, does the same thing, but better structuring. A simple multiply file or multiply.test.ts file, which has the multiply block, sum.ts file, test.ts file, which has the sum block and has the 3 test cases. That is how you write test cases for a simple application that looks like this. But in the real world, of course, there are more complex applications. We create HTTP servers sometimes. So let's understand, how can you test HTTP servers? That's going to be the next slide right here, slide number 3, testing an Express application. All right, testing an Express application. You can follow all the instructions here, or I'm just going to build on top of the project that we're currently building. Right now, if you ignore all the tests, then what is the one file we have? It is index.ts, which has most of our code. This is raw JavaScript code or TypeScript code. We want to now convert this into an Express application. So step 1 is installing Express. Npm install Express at types/express. And then creating a simple Express server, nothing too complicated. Let's do a app.post on /sum, which gets 2 arguments, A as rec.body.a and B as rec.body.b, creates a result called A plus B, and then finally returns. Doesn't even need to return it. Rest.json result, which is going to be the sum. We can also do something like this. So now we have HTTPified our sum function. Earlier, it could be called here. Now, people all around the world can, hit this specific endpoint if you've of course deployed it on the internet, and get back the sum. If I run tsc-b followed by, I need to delete the tests now because the tests were for a separate function that doesn't exist anymore. I also need to add one more line here called app.listen to actually start listening on a specific port. This is what we should ideally do. This works if I write tsc-b followed by node dist/index.js. You will notice now if I go to localhost :3000/ sum with 2 arguments, A which is 1 and B which is 2, it returns me nothing because I have not used app.use express.json middleware. If I try one more time, you will notice I get back sum as 3. This means our server is working as expected. But if you remember, I told you that whatever you're writing over here that needs to be tested needs to be exported so that the tests can actually import this. Here comes a small dilemma. Whenever you'll be writing your tests, you will be importing app from here, and that would start an HTTP server. Usually, or more specifically, the library that we will be using for testing automatically starts the HTTP server. And hence, you don't want the tests also start the HTTP server. The tests also run app.listen, and we also run it manually. So usually you will see whenever you have tests in an Express application, the listening logic exists in a separate file called bin.ts. Bin stands for binary. Okay, this is going to be my final binary file that will run. And here you import app from index.ts, and here you call app.listen. Now, whenever you want to start your application, you will not do node dist/index.js. You will do node dist/bin.js. It tells me something is already running on port 3000. Let's try that one more time. Oh, I forgot to save index.ts. Let me save this. Let me save this. And now let me run it. And as you can see, this is how we need to start our application. Whenever I deploy this on AWS also, this is the command I will run. I will not run node dist/index.js. If I run this, it will not work because there is no app.listen over here. Why is there no app.listen over here? Because if I add an app.listen, then the tests will also start to listen on port 3000, and they will start their own server also. We will have two HTTP servers, which is something we don't want. Another reason you don't want to do it is if you run tests twice, if you ever run npm run test twice, both of them will start something on port 3000, and that means there will be a port conflict. One of them would fail. Hence, you take out the listening logic into a separate file. Index.ts simply defines your Express application and defines all of your routes. You can also structure your routes better, have separate routes folder, create an MVC pattern. But even if you have it in the same file, it's fine. Either way, you don't listen in this file. Listening happens in a separate file. Given you have this, how can you test it? Harkirat, you told me I can create a sum.test.ts file. Here I will import it and describe from jest/globals. I will also import, there is no sum function. I will import app from /index. And then Harkirat, I need to now test this app. But the question is, how do you test it? I can write a describe block, tests the sum function. And here I can define an it should return 3 when 1 and 2 are added. But how do I hit the HTTP server? I cannot do a app.post over here. I actually need to do a axios.post. Okay, something will start on some post. And I need to hit the sum function with these arguments. A is 1, B is 2. This is what I ideally need to do in the test. But here you need to know what URL to send request to. You need to understand what data you get back. And you can do this as well. But there is a library called supertest. If you go to npm.js supertest, you will see it says the motivation with this module is to provide a high level abstraction for testing HTTP. What are we testing? An HTTP server. Can we test it like this? Yes, we can. If I do an npm install Axios and then start the HTTP server first and then start the tests, this will work. I can do a const res equal to await axios dot whatever and then do a expect res dot data dot sum dot to be 3. Whatever, answer to be 3. Something like this. I can do this. And there is no downside here. The only downside is you need to start the HTTP server. You need to know the port of HTTP server. If you start it on a static port, then you can't run two test suites together. You cannot run npm run test twice. And hence, that's just one downside. But you can totally do this. This was how we used to do it before libraries like supertest were introduced. But supertest lets you test HTTP servers in a slightly more easier way. First, you have to install supertest in your application. npm install supertest at types/supertest. And then in your tests, you do something like this. You use the request object that comes from the supertest library. So you import request from supertest, which is whatever this exports by default. You put it over here. You don't put brackets around it. The default export is what you get. And then rather than doing this, you do this request on the object or app object. I want to create a post. Let's see what the syntax is. Yes, I want to send a post request to /sum. And I want to send it with these arguments, 1, b2. So you have to understand the syntax of the request library. As you can see, it expects you to call .post rather than, you giving a URL. It expects you to call .send rather than simply being a simple axios.post call. So the syntax you have to get comfortable with. There isn't too many things to learn in the syntax. You give it the app object so that it knows what HTTP server it is trying to test. And then you simply tell, hey, if you send a request here with these arguments, you get back a response. And then you can expect on that response something like expect rest.data.answer.2b3. Probably is something else and not data. Response.body something. So body.answer to be 3. And now you're doing tests very similar to this. You are still starting an HTTP server. You are still sending it a request, but it is all handled by the supertest library. The request object here is what you use to send out a request. And then, you assert on the response. You can also assert other things. Rest.status code should be 200 because we know we're sending it the right thing over here. And there's nothing erroneous in what we're sending. So the status code should be 200. If you look at the code as well, we never change the status code. We always send the 200 status code. And hence, whatever code we have written here should hopefully work. Let's see if it does. To quickly recap, we have added our first test where we are using the supertest library, giving it the app object, which is the object or the instance of Express over here, where we have added all of our routes. Notice this file now doesn't have an app.listen. We don't need to start the HTTP server. The library does it for us. Then we expect on the answer, status code, things like these. Let me run npm run test. And you will see it fails because we get back undefined. rec.body.answer. And what are we returning? We are returning sum. That is why you write tests to, confirm you're giving the right key over here. I was giving the sum key. I should ideally give the answer key. Now, if you look at it, tests are working. Can you make this more complex? Can you add a multiply function now? /multiply, which needs to return the multiplication of A and B. Can you now write a test for it? Here I've written the tests for sum. Let me describe a new block called multiplication, where should return right value if one value is 0. And here I'll do a const as equal to await request app dot post /multiply dot send. A is 0 and B is, let's say, 100. What should the response be? What should I want to assert on now? I want rest.body.answer is 0, because 0 into anything will be 0. And I can, of course, check the status code just like I have here. But let's see if this much test, number 1 runs, number 2 succeeds. So now, as you can see, the first test suite ran with just a single test. The second multiplication one ran with just a single test. Can I add more tests? Yes, I can. If I go to the multiplication block, I can add another test that, finds the sum of value if one number is negative. So if I do a minus 2 into 1000, the final output should be minus 2000. And if I run this, you will see first one ran and second one had two tests to run. One if the one value is 0, other if one of the value is negative. That is how you write and run tests for an Express application. You use the super test library to delegate starting the HTTP server and getting back responses like these. Can you still use Express Axios? You can, but this is probably standard thing you'll see across most code bases. So just use super test than writing your own thing. Yeah, that's how you create it for an Express application, a simple Express application. What if I add some constraints here? What if I say, if a is greater than some very big value, 10 power 6, then return res.status 411.json message, sorry, we don't support big numbers. What if our application now needs to restrict only if a is less than this thing? If either one of them is greater than some value, then you let the user know, hey, sorry, we don't support this. You're trying to use too much compute on our machine. We support sum of very small numbers. Now, our coverage will decrease. I repeat, whatever test we've written, never hit this code base. For the single test that we have here, which finds a sum of 1 and 2, which sends these two arguments, code reaches here, these two lines run, and then these three lines run. These lines never run. So we have decreased our code coverage. We are not covering enough code using tests. And hence, we should also write a test case that covers this branch right here. Else, you're not ever testing this test case. So if, by mistake, a developer comments this code out, tests will still succeed. And no one would know that a code change that is a blunder has been checked in. And hence, you should also test this specific branch. How do you test it? You can write another test here. It should fail when a number is too big. And then, send a very big number for a. Now, what should res.status code be? What is the status code we return? We return 411, and hence this should be 411. Why did I pick 411? It's just one status code that is used for, wrong inputs. Length required. It's actually not the right one. I keep using this because this is what I have in memory, but think of a better status code. Status code wrong inputs. Let's see. 422 unprocessable entry is probably a better one. So let's replace this with 422. Let's replace the tests with the actual implementation to also return 422 status code along with some message. What is a status code, Harkirat? You have to go back to the Express class if you don't know what status codes are until now. But yeah, that's a brief of how you add more coverage. Now the code will reach here as well, and this branch will also run. What should rec.body.answer be now? It should ideally be undefined because, as you can see, we're not returning any answer here. But ideally, we should assert on this. We should check, are we getting back a message? And if we are, does it say this? Sorry, we don't support big numbers. So that's what you assert on here. You also assert the status code. If I run npm run test now, you will see 4 tests pass, which means this test is working correctly. And this test is also able to test an extra branch that we had just created. So whenever you add these branches, right, whenever you're updating the code, unless you've added tests, you will end up decreasing the code coverage. So you should always make sure if you've added any code base to your project or any change to the overall code base, you are testing it. You are making sure that whatever you have added actually gets executed at least once in all the tests that exist over here. That's what's called code coverage, and you need to aim to increase the code coverage. That's it for how you create a simple Express app and test it, and then how you create a slightly more complex app and test that. If you go to the slides, you will see slide number 2 covers the basic application. Slide number 3 covers a more complex endpoint. In slide number 4, the complex endpoint uses Zod. It pretty much makes sure that the user cannot send us any erroneous inputs. So this is another, complex branch that can run. If the user is sending you some wrong inputs that doesn't follow this format A:B, then this branch runs and lets them know, hey, incorrect inputs. We did something very similar, right? If you go to our code, in our code, we checked if A is bigger or B is bigger, then we return early. For these guys, they check if the input response is not correct, then you return early. That is what Zod lets you do. If you look at the tests now, very similar. Should return 411 if no inputs are provided. If I try to send it erroneous inputs right now, which means I don't send an A or I don't send a B, or if A is an object or B is an array, then it will be caught over here in this if statement, and 411 is what will be returned along with incorrect inputs as the message. That is exactly what is being tested over here. Here the status code is 411 and the body says incorrect inputs. That is how you test a slightly more complex Express application. Try to write this yourself, try to write some extra tests, maybe create 4 endpoints, one for addition, subtraction, multiplication, division. Try to write tests for all of them, try to separate them into various files and push them to GitHub. It's a good, kiddie assignment to do before we move on to some real Express servers that also have a database. After this, if you look at it, we're going to move from Jest to VTest really quickly, and then we'll add a database to our application. This is where things get complex. This is where you need to understand about mocking as well as spying. Let's get into that next. Let's understand first, how can you move from Jest to VTest? Do you even need to move from Jest to VTest? Answer is no. VTest provides you the same things that Jest does. VTest has been made to be highly backward compatible. It has been written by the same people who've written Vite. If you remember, we've been using Vite to start our React applications from time to time. So this is a new testing framework. It's being developed on much faster. It's TypeScript first versus Jest was not TypeScript first. Eventually some libraries were added to add TypeScript to it. So generally a good one to follow. There are a few controversial takes on this, doesn't matter either way. You can use Jest as well. The way to do mocking in Jest would be different than the way to do it in VTest. But for these slides, just to explore more than one framework, we're going to move from Jest to VTest. Thankfully, and here is some more reasons as to why you might want to move from Jest to VTest. Thankfully, VTest is highly backward compatible with Jest. What do I mean by backward compatible? I mean that they knew these are the functions that you use from @jest/globals. And they said, we are going to give you the same things. If you have an existing Jest code base, all you have to do is this. Rather than importing from Jest, you import from us and then you're good to go. That's what makes it highly backward compatible with @jest/globals, or the Jest library. So if I now just do a npm install VTest, followed by an npm run test, you will see some errors pop up because I think there's one more thing we had to do. Oh, yes. We forgot one thing. Do you know what I forgot? I forgot to replace package.json to call VTest instead of Jest. So there are two things you have to do. Now, when the user runs npm run test, you want VTest to run and not Jest. That is why the tests were failing. If I now run npm run test, you will see tests are now running very similar to Jest. What did I have to do? I just had to do a npm install VTest followed by replacing the scripts section in package.json to use VTest, followed by wherever I am importing, I am going to import from VTest. That is all I had to do. And I was able to migrate from Jest to VTest. You can also stick to Jest, but the way we're adding mocking slowly is slightly different between Jest and VTest. Now that we have this, now that we have migrated over from Jest to VTest, we're going to understand how can you introduce a database to our code base. And given you have a database, how do you test if your application has a database? What is a unit test and what is an integration test? How do they differ? And how do you write unit tests? What is mocking, what is spying is what we'll understand next. All right. Step 1 is adding a database to our code now. If you go to the GitHub repository, you'll find 5 Express vTest Prisma where we've added a database to our code. I'm going to do the same thing for the code that we are writing right now. If I open Visual Studio Code, along with the tests, I have the /sum functionality and let's say the /multiply functionality. Now I want to store this in a database. Now you can use Postgres, you can use Mongoose, or we can just use an ORM like Prisma like we have for a really long time now and start to store this in a Postgres database. The steps there are: first you install Prisma as a dependency, taking a long time. We will wait. And then do a npx prisma init to initialize a schema.prisma file. Here is where we'll be writing all of our code. For example, I can create a new table called, let's say, calls, which means all the user requests, I guess is a better name. Requests, each request has an integer ID and it has a type, which ideally should be an enum. So you can actually define an enum here called request type, which will have two types. You can either let the user do a sum or do a multiply. And the type here is going to be of type request type. What does an enum let you do? It lets you create variants for this specific thing here. We want type can only be one of these two. It cannot be a third thing here called something else, AST. And hence you can restrict that by creating an enum. If this seems jarring, you can just stick to strings for now and eventually add request type. Then usually whenever you're doing any request, you're doing it on two numbers. So we can do A, which will be the first number, and then B, which will be a second number, and then maybe answer, which will be the final answer when the numbers were added or the numbers were multiplied. Let's say this is what we're trying to store into our database now. We have created the models for it. We need to migrate our database. If you remember, we need to, number one, get a Postgres database. Then we need to create all the tables in that Postgres database. The good thing about testing is you don't actually need a database. What we are doing right now is what's called unit testing. Unit testing means, if this is your Express application, right? This is your Express application, your main Node.js code. You might have multiple external services you might be talking to, be it a database like Postgres, be it Kafka, or be it Redis. Whenever you're testing the code, you will mock out, I repeat, you will mock out all of these external dependencies somehow and only test the logic of your code. You will not test, hey, is this request succeeding? Are these requests failing? You don't want to test that in a unit test. And right now we are doing unit testing. When do you actually start a database and test everything? Is when you do integration tests or you do end-to-end tests. We will discuss both of these in our last slide. But right now we are writing unit tests. The good thing about writing unit tests is you can create your whole application. You can write all of your index.ts code and you can write corresponding tests in a separate file. Let's say index.test.ts, and you don't even need to start a database. As long as your tests are written correctly, and as long as you assume eventually the database will be brought up the right way and the database will do what it's supposed to do, you will be able to test without ever creating a database, without ever creating a test Kafka instance or creating a Redis instance. That is the benefit of using unit tests. But what is the downside? The downside is you're not actually testing database calls or Kafka calls, which may lead to some problems in your code base because you haven't really tested the insert functionality or the update functionality. We'll eventually maybe get to integration tests as well, or we might get to end-to-end tests where yes, we will actually start these services. But right now, since we're doing simple unit tests, we will simply mock out these services, which means I don't need to start a database right now. I don't even need to migrate a database. Eventually, when I deploy my application, I will. But right now, since I'm writing tests, all I need to do is generate the Prisma client. If you remember, there were two commands that we ran, npx prisma migrate dev, to actually migrate the database, to actually create a bunch of SQL files and run them on a database. But since we are just writing unit tests, we don't have to migrate the database. We don't even need a database. We can simply do npx prisma generate to generate the Prisma client. What is the Prisma client, Harkirat? If you remember, Prisma client is these set of files right here, node modules /@prisma /client. This is what I've just generated by running this command. Why is it beneficial? It is beneficial because now I can start to hit my database. I can create a new Prisma client and call functions to insert things in the database. Harkirat, even without starting a database, you can do it. Yes, since we will be mocking out all the database calls, which will come to very soon. Since we'll be mocking out these requests, we don't even need to start the database. All we have to do is generate the client and then write the code that actually does the database insertions. I probably need to do a database insert over here as well as a database insert over here. So let's create a new file called db.ts, inside which I will export the Prisma client. I will do import Prisma client from @prisma /client and export const Prisma client equal to new Prisma client. Harkirat, why did you not do this directly in index.ts? Why did you not write this line of code directly at the top over here? Why did you create a separate file for it? Well, number one, better structuring. But number two, as I've been saying, we will be mocking out these requests. Whenever you want to mock out something specifically, this is the thing we will be mocking. What does mocking mean? What's mocking mean? We'll be changing this specific export when we're running the tests. It will no longer be initialized to this. It will be initialized to something dummy. Mocking means making this thing dummy, making sure that whatever is being exported from here doesn't actually hit the database. It's some dummy function that you can call. Hence, we put this in a separate file. We import it over here. Import Prisma client from ./db. And then now I can start to, number one over here, do a Prisma client request create. And what will we put? We'll say A is this, B is this, result is A plus B. And then lastly, what was the schema again? A, B, and answer. So answer is, I can actually move this one line below to reuse the result variable here. Answer is result, and operation is going to be this sum variant, which I think needs to be something like this. Or is it something else? It is type. Type needs to be sum. We can actually get it from somewhere as well, but let's just do this. We can actually get this as a constant from somewhere in Prisma client, but this is fine as well. This is how you insert something in the database. And then, of course, we can do the same thing over here, where we can say the type is going to be multiply. This will be an async function. And there we go. We have another insertion over here. I have added the Prisma code to actually put something in the database whenever a request comes to /sum, as long as it's a valid request. If it's an invalid request, then we don't do anything. It gets early returned here. But if it is a valid request, then control will reach here, then it will reach here, then we will insert something in the database. The same thing is happening on the /multiply endpoint. Control reaches here, you put something in the database, and then return to the user. Harkirat, why did you not have validation here? We can add it just to show it added in one place. You can add validation in the other place as well, and make sure inputs in both the places don't exceed a certain number. I have written the code to put things in the database, but how do I test this? Should I start index.js? If you remember, I had created a bin.ts that actually starts the application. So should I do this? Should I do a tsc-b followed by node dist/index.js and dist/bin.js and actually start the database, the HTTP server? What would happen if I do that? If I go to Postman, try to send a request, it will error out because the database doesn't exist. We have not authentication failed against the database server on localhost. There is nothing running on this database that's mentioned in .env. This is some random database. Nothing is running on localhost :5432. And hence this is not the right way to test it out. Harkirat, we wrote tests. We can do that. Let's go to tests/sum.test.ts. And here, Harkirat, we have already written the logic to test it out programmatically. So this will work. But will it? What does this do? This actually sends a request here. Database is still down. There is no database running. So wouldn't the tests fail with the same error? When you are going to Postman and sending a request, why is it failing? Because there is no database running. Wouldn't the same thing happen over here? If I run this specific test that we had written that sends a request to /sum with these arguments and makes sure that the body is correct, answer is correct, status code is correct. If I run npm run dev or whatever, tsc-p followed by node npm run test over here. If I run this, the same error will come. As you can see, test is running because exception came, control never reached here, test never passes, and then it errors out. Still works. This test still works for some reason, but the other one doesn't. Can you guess why this test succeeded, but all the other tests failed? This test still succeeded. Take a pause and figure out why did this test, in which I'm sending a very big input, not fail. This is the endpoint that it hit with a very big input. Control reached here, and it got returned. The database call never happened. And hence, one test for hours succeeded, but all the other ones failed here. Whenever you're trying to connect to the database, the test is like, sorry, there is no database running. Of course, the test will fail, as it should. There is nothing wrong in it. It is expected to fail. If you go to the slides, that's exactly what happens at the end of the last slide, which is you will see this error. You're supposed to see this error. How do you fix the error? How do you introduce? If I go to the next slide, mocking. I talked about, you need to mock out the database calls, but how do you actually do it? What does mocking mean? What is the erroneous line over here? It is this line. When the control reaches here, there is no database and hence the request fails. What if this happens when the test is running? What if you could somehow mock out a request so that either nothing gets called, but a mock, ideally what happens is a mock function gets called. What is a mock function? Basically, an empty function, something like this. Function mock. Wouldn't it be nice? When the tests are running, just call an empty function and proceed. Ignore all the database logic. That is what mocking lets you do. Harkirat, this sounds wrong. That means our tests can be flaky. Yes. Unit tests are meant to test this logic. If something is greater than something, then control reaches here. Else everything is fine. Things get returned. Unit tests are not supposed to test external services. They are not expected only to hit any external service. They should work in isolation. Even if your server where the specific tests are running, if it doesn't have a database, if it doesn't have a Kafka instance, your tests should still work, which is why we want whenever any of these test files run this code, this gets mocked out. This doesn't get called. An empty mock function gets called. We only want this for tests. If I actually run the application, then though of course we will have to start a database and actually make this database call. But during the tests, we only want to test this functionality or the final result functionality. We don't care. We totally ignore / assume that this will work as expected. So we are not going to test this. Database will do its thing. Prisma client is probably doing the right thing. Hence, we need to mock out Prisma client. We need to tell the tests, okay, when you're running the code, right, this specific variable needs to be mocked out. This specific variable needs to call a dummy function, or more specifically, Prisma client dot request dot create should be a dummy function. We need to tell the sum.test.ts file this. How do you do this? How do you tell all the tests, or specifically all the tests that are in this file right now, okay, hey, please mock out all the requests from here? The answer is actually fairly simple. You can create a mock at the top of this file. All of this is present, of course, in the documentation. But if you look at it, what does it say? It says, okay, if there is a file that you want to mock out, let's say there is a file that exports a function called method. In your test file, import the method and then simply call v.mock the thing that you want to mock and the method name you want to mock. You don't even need to import it actually. All you have to do is v.mock, where v comes from the vtest library, the path to the file that you want to mock, and what should it return now. Right now, what is our file returning? It is returning a Prisma client variable. It's pretty much returning an object that looks like this. Prisma client, and then some very big Prisma client object. This is what it's returning right now. What do I want to mock it out to? What do I want it to return? I want it to return something like this, yaar. It should return a key called Prisma client, but that should have a request key inside it, which should have a create key inside it, which should be a mock function, something like this. I don't want during the tests to use this. I instead want this file to return this. Harkirat, why this complex object? Why did you not say I want to mock out Prisma client? Why are you saying you want to mock out Prisma client dot request dot create? And the answer is, if you go to index.ts, what am I using? I'm using Prisma client dot request dot create. I want this whole function to get mocked out. If I only mock out Prisma client, then Prisma client will be a mock function, and Prisma client dot request would be nothing. Dot request dot create would be undefined, which is why I have to tell it here, this is what you have to mock out, not just Prisma client. Eventually we'll be getting into deep mocking, in which case you don't have to do any of this. But right now, you will have to go through your complete code base and figure out here, where all do I have database calls? If I have a Prisma client dot request dot update call, then I need to add update here as well. Here, update call also needs to be a mock function. So I need to keep them in sync. All the database calls that I'm running during my tests, I need mocked out over here. Let's see how you can do that. Thankfully, we are simply using Prisma client dot request dot create, and hence all we have to do is, if I go to sum.test.ts, I have to import v from vtest and do a v.mock /db. I think that is where db.ts exists, /db. Okay, I want this file to be mocked, and it should return a function called Prisma client, which should return a function called request, should return a function called create, which will be v.mock. something like this. I think this needs to change a bit. v.mock, okay, it returns a function. So I have to do this. There we go. v.fn. There we go. That is what we have to write at the top of our sum.test.ts file. And now anywhere in index.ts, Prisma client.request.create is called. It will be replaced by a mock function. You don't have to worry ever about this hitting the database. This will not call a database call. This will simply call v.fn, and hence this will sort of become a dummy call. This is almost equivalent to getting commented out. So our tests will work as expected. You might still think, this makes our tests very flaky. And that is true. Unit tests are supposed to be not flaky, but they're not supposed to test everything. The name itself is unit tests. I just want to test this unit. I do not want to test any external service calls. Let's see if the tests succeed. If I add just this much code base, you will see all the tests succeed now. What if I change this to from create to update? Then it will begin to fail, of course, because the create function will not get mocked out. So you need to make sure you are mocking out the right functions. If your function calls for Prisma client include.create, that is something you need to mock out. If in the future you add .delete, you will have to make this mock more and more complex. This is a problem. We should fix this. We don't want this becomes so big. What if in the future you have a users table and then you will have to mock out this as well? Find many, create many, so on and so forth. There is no end to how many of these mocks you will have to create. So wouldn't it be nice if somehow you tell it, hey, mock the whole thing deeply. What does deeply mean? It means figure out all the keys that already exist on this Prisma client and mock out everything. If someone calls Prisma client.request.find many, it should be mocked out. If someone calls Prisma client.users.create, it should be mocked out. That's called deep mocking. The word deep comes from deep copying. If you've heard of deep and shallow copies, deep copying means you copy over every key inside to a new object. Shallow copies mean you have some references and some copies by value and some copies by references. If you did not understand it, it's fine, Google it. But the word deep comes from the fact that I don't want just request to be mocked out. I want every key that exists at the very depth to get finally mocked out, and so that I don't have to maintain all of this logic at the top of my file. I can simply do a v.mock and it just works. But before we get into deep mocking, do we understand what we did here? We, number one, introduced a bunch of database calls. The sum endpoint now not just does this validation, not just finds the result, it also stores it in our database and returns it to the end user. Same for the multiply function. It gets the inputs, creates the result, and then stores it in the database, returns it to the end user. That is how you do sum and multiply with a database. And since we have introduced this database call, we have mocked it here at the top of our test file. If I create another test file, I need to add this code over here as well. If I create a separate, multiply.test.ts where I've run this logic, then over there I need to add this at the top of the file as well. This mock is file specific. So if you have multiple test files, at the top of every test file, you need to introduce this logic. Now let's understand, how can you just do this much? Just mock the whole thing in a deep fashion. I don't want to worry about, maintaining the mock myself. How can you deep mock the Prisma client that exists in database.ts? That's discussed in the next slide right here that says deep mocking. Another way to mock variables is to let vtest figure out the types of the mock and types and mock out the attributes of objects being mocked. Basically, if you try to log Prisma client, right, or in specifically object.keys of Prisma client, which means What is the shape of Prisma client? How does it look? You will notice it has a bunch of keys. Some, or in our case, request is just one key. Let's try that. Let's do a console.log Prisma client over here. And let's try to run the application, not using tests, but using actual node dist / min.js. Why not using tests? Because tests mock it out. We have this logic at the top. It will mock out the Prisma client. So we don't want that. We want to actually see the Prisma client. If I log it, you will see a very big object. It's too big to even fit into my terminal. And hence I logged object.keys, which means, as you can see, it's a very big object. The top level keys of that object. What do I mean by top level keys? I mean, if my object looks something like this, name is Harkirat and address is an object which has, city and country, then object.keys should give me name and address, the top level keys of this object. If I log just this much, you will see we have a lot of keys. Request is just one of the keys. There are a bunch of others. And if I do a object.keys of prisma.request, you will see the request object itself has find unique or throw, find first, find many, create many, so many things that need to be mocked out. And hence, rather than putting all of these keys over here, acha create is also there, and then what else is there? Acha count is also there, that's going to be v.fn. So what else is there? Aggregate is also there, so on and so forth. Rather than you figuring out this, you can deep copy the Prisma client object. You can deep mock it, which means everything towards the end. Prisma client.request.create will be mocked out. Prisma client.request.find many and return will be mocked out. Everything will be mocked out. Let's see how that happens. vtest gives you another library called vtest mock extended. As the name suggests, it extends some mocking functionality on top of vtest. If I introduce this in our code base, number one, I need to introduce this in our code base. Number two, I'm going to introduce something new, which isn't related just to deep mocking. It works without deep mocking as well, which is if you ever want to mock a file, right? If you ever want to mock, let's say db.ts, which is something we want, you can either put the final object that you want it mocked as over here. You can either put the final object that you want to mock it as here, or you can create a folder in the same directory as your file that you want to mock. So if I want to mock bin.ts, in the same directory, I will create a folder called __mocks, inside which I can add db.ts. So if this is the file I want to some mock for tests, I can create a __mocks folder, inside which I can add a db.ts. And here, if I simply do export const prisma client equal to the thing that I had here, I can get rid of all of this logic. I can move this second argument here. It's a little cleaner. Rather than having all of this logic, this big object here in sum.ts at the very top, I can simply say, hey, v.mock./db. And since I have created a mocks folder, when it tries to go to ./db, it understands that I am here, ... I would have gone to db, but since there is a __mocks folder, I will go here and find what the final thing looks like. So this is irrespective of if you're doing deep copying or not, or deep mocking or not. This is another way to put the second argument in a separate file. You can either do this or just create a separate file at the same level as db.ts and then put this logic over there. If I now run npm run test, you will see everything still succeeds. Why? Because I've said the create function is going to be v.fn. If I run this again, it works. If I remove the create v.fn, then you will see it begins to fail because the create call hasn't been mocked out. If the create call isn't mocked out, then of course this Prisma client.request.create will begin to fail. So that is how you need to, that is another way to structure your mocks, is to put them in a __ mocks folder and export everything from here. That is step 1 of what we've done in this slide. Step 2 is deep mocking this. Somehow letting V figure out all the keys of Prisma client and mocking every key so that you don't have to create a complex object. V creates it for you. How can you do it? We just installed the vtest mock extended library. Rather than doing this, you can simply export const Prisma client and say that it's a deep mock deep of the Prisma client variable. This basically means it'll figure out all the keys that exist on a new Prisma client and mock everything inside. It will do something like this: const Prisma client equal to request create v.fn, update v.fn, so on and so forth. It will create all of these mocks for you so that you don't have to create them. That is what mock deep, a library that vtest provides you, lets you do. Why is this useful? Because now you don't have to maintain everything. All the keys have been mocked out. Your tests will just work. If I do an npm run test, it works. Why? Because Prisma client dot request dot create is already mocked. If I run this and try to log Prisma client dot request dot create, there you see, as you can see, it is a function which is a mock function. It has things like get mock name, things like that. It is not undefined. I did not have to specifically do something like const Prisma client equal to object, which has request as a key, which has create as a key, and then, v.fn. I did not have to do this. It automatically happened because I mocked the Prisma client deeply. What would have happened if I do not mock it deeply? Then Prisma client will become jest.fn and Prisma client.create would be undefined. That is why if you have such a complex object, by complex object I mean it has one key which has another key, which is the thing that needs to be mocked out, you can simply use mock deep to mock out the whole thing. If I run npm run test, everything works with such clean logic. I don't have to create a top level complex object. I simply do v.mock /db over here, and in db.ts I simply do export const Prisma client equal to mock deep Prisma client. It exports the Prisma client that I can use over here, that vtest just picks up automatically. If I did not export this but exported my own thing, then also vtest would pick up, as long as it's present in __ mocks __ and the file name that you want to mock out, which in this case is db.ts. If I create another folder here called, I don't know, utils, which has another folder here called, let's say, users, where I have, some index.ts file. If I want to mock this file, then I will have to create a __ mocks function in users. In users. So these mocks need to be right next to the file you want to mock out. If you want to mock out this index.ts, then you will have to create __ mocks /index.ts, where you will export whatever, let's say this index.ts export const user equal to user1. And then in __ mocks __ I can be like, or maybe user function is a function which returns user1. And in __ mocks __ /index.ts, I can say export const user fn equal to v.fn. So that whoever uses this, as long as at the top of their file, they have written v.mock / utils / users, this function would be mocked out to return nothing, versus ideally it returns this right now, But since we're mocking it out, it will return nothing. If I log that, if I go to sum.test.ts, and somewhere here, let's say I import user fn from not just mocks, from this itself, and then log it. What do you think will get logged? What does user fn return? It returns some string over here. But what have I mocked it as? I've mocked it to simply be v.fn. Don't return anything. Harkisat, how can I return my own thing here? We'll get to that in the next slide. But right now, it gets mocked out to an empty function. Harkisat, why did you do this? Let's say there was a database call here. I've written a simple function here, but let's say this function did some database call that you don't want, to do during a unit test. And hence I have mocked out this function where I've mocked it out in __mocks__index.ts. I did not put it in the global _mocks. I had to introduce another folder right next to where index.ts exists. If I run the tests now and look at the logs, there is an error. Let's try to debug it together. User fn is not a function. It is a function here, and export cause user, small f. Let's try that one more time, and you will see everything happens, and it returns undefined. It does not return this thing. What happens if I remove the mock I had here? Then it will return the actual string. What happens if I add the mock here? Then it will return undefined because user fn is undefined. So that's how you mock out a specific function call / file by introducing the __mocks___ folder. You don't have to do it directly over here. You just have to make sure if this is the file that you want to mock, the __mocks folder exists right next to it. You shouldn't introduce it here in the global __mocks folder. This was introduced because we had a db.ts file here. And this was introduced because we had an index.ts file here. That's all for mocking and specifically using __mocks__. But there is a small problem here, which we'll be discussing next. If I go back to the slides and show you, towards the end, I've written some logic that will cause some problems. That will lead to us understanding what are spies and how are they different from mocks. Let's get into that next. Alrighty. I've cleaned up the code a little bit so that we don't deal with the things that are not needed. We now have an index.ts file, which has two routes, the post endpoint for sum, as well as the post endpoint for multiply. We also have the tests for it in tests/sum.test.ts, where we first send a request to sum with 1 and 2 and expect it to be right. Then we send a request to /sum with incorrect inputs and expect it to return a 422 with a sorry, we don't support big numbers. Then we have a describe block for multiplication, where we have two tests. First, in which we assert that 0 plus something or 0 into something is equal to 0. And the second one in which we assert that if one of the values is negative, the final output is negative as well. If I test this code by typing npm run test, you will see all the tests succeed. And the reason for this is at the top of this file, I have mocked ./db. What is the original implementation of ./db? It exports the Prisma client. What have we mocked it to? We have mocked it to deep mock the Prisma client, which means all the keys that exist here have been mocked out. This translates to this line of code and this line of code calling an empty function when the tests are running. When the application is running in the real world, then of course the real Prisma client will be called and a real database call would happen. But whenever the tests are running, this will call an empty function. This poses our first problem. What if you also want to return the ID of this database request that was made in this request? What if you want to do something like this? Const request equal to await this thing, and then finally return a ID as well. This looks like a legitimate use case. Whenever a user is trying to create an entry for sum, we return them the result as well as the ID of what's being stored in the database. This works when we're trying to hit this via Postman. When you hit this via Postman, of course, this will hit the database. There will be an ID that will be created. If you remember the schema, if I go to prisma/schema.prisma, you will notice every request has an ID. It is auto incremented by default. So 1, 2, 3, 4, 5. Like that, IDs would be stored. And all of these IDs, what if you want to return to the end user? Can you guess what the problem would be now, specifically over here? If we mock out Prisma client, what would happen? This whole thing would return an empty function called v.mock. And v.mock is a empty function. It returns nothing. It returns undefined, which means request will become undefined and request.id will throw a runtime error. Let's see this in action. Let's press Command Z a few times. The only change I have made is added const request equal to in front of this and try to access the ID over here. If I try to run npm run test now, you will notice the first test is sort of stuck. And after some time, you will see what the error was on the first test. It says cannot read properties of undefined reading ID. It means it's trying to read ID over here. But since request is undefined, since this was mocked out, it returned undefined and hence request.id cannot be accessed. Here is when your test is now failing because you used a mock. This is where, mocks get a little flaky. They cannot test everything. And they can sometimes break your runtime logic. If you are dependent on what the database returns you, then your runtime, some exception can happen because you are mocking out the whole thing. What you need to do is mock out the thing as well as mock out the return value. If you can mock out the whole thing and give it some mocked return value, is when this error will go away. If I can somehow say, okay, this is going to return a mocked return value. The prisma.request.create, irrespective of what the inputs are, is going to return a mocked value. Then I can have that mocked value to have an ID key and not be undefined. The question is, how can you make something return a mocked value? How can you tell the tests, this thing is mocked, but the Prisma client dot request dot create function is not v.test or v.mock. It is something else. It is a separate mocked function which returns you a value. The answer is you can use the mock return value construct that vtest provides you. Let's see how to do that. If you go back to the slides, you will notice there is a slide 10 out of 13 that shares how to mock return values. You can mock the values returned by a mock. You can return some specific values from a mock by using mock resolve value. How can you do it? You can do something like this. You can import Prisma client from, I think you can just do this as well. You don't need __ mocks. You can import Prisma client from /db. We still need to do a v.mock of /db. But here, right before you send the request, I repeat, right before you send the request, you can be like Prisma client dot request dot create dot mock or something similar. Mock resolved value dot mock. You do need it to come from __ mocks then. Mock, there we go, resolved value and whatever value you want to give it. For example, ID1, sum or whatever, result 3 and whatever, answer 3 and what are the other fields here? A, B and answer and type. So type will be sum, A would be 1, B would be 2. You can say yaar, this specific call, the Prisma client.request.create call, mock should return a mocked value which looks something like this. It should not return undefined. It should return something like this. Why is this good? Because now whenever Prisma client.request.create would be called, it will return you a mock value which you have defined over here. Right before I make this HTTP call, I say, here this function should return a mocked value, which is this. And we get this mocked value here during the test runtime. Let's try to log request and see what we get back. If I do a npm run test now, number one, notice all the tests are passing. Number two, notice ID1 answer 3 sum AB is being returned in this request object, and hence our runtime isn't failing. Our tests aren't failing at runtime, even though we don't have to assert anything on the request ID. If you go back here, I am never asserting anything on the request ID. I can, if I want, I can be like, hey, ensure that rec.body.id exists to exist, not exists. To, there should be something to be, and we can do 3 over here because we know, sorry, the ID we're passing is 1. So we can say, hey, make sure the ID that's coming back is 1. And that's probably anyways a better test. Let's try that. All the tests are passing. And now I'm checking not just the answer to be 3, but also that the request.body.id is 1. If the database call returned 1, the same thing should be passed to the user here. This will help us catch errors like this. If the developer was dumb one day and by mistake returned B from here, then this test will be able to catch that. If I run npm run test now, the test fails because the developer, rather than sending request.id, sent request.b, and we are checking in the tests here, whatever the database call returned, this ID:1 is what should be fetched from this HTTP call, and hence this expect begins to fail. That is why mocking makes sense, or mocking returned values makes sense when you are dependent on return values. If we weren't dependent on this, then it doesn't matter. We're not using the return value. But if you are using the return value, by default, a mock will return undefined, and you should mock out the resolved value in case you want to do tests like these, or generally if you want to get away from runtime errors like we were getting when request was undefined. If I run the tests now, you will see all of them are succeeding. If the developer makes any code change that's erroneous, by mistake changes this to B, the tests begin to fail. If they fix it, the tests begin to succeed. That's the benefit of using a mocked return resolved value. Now, what does resolved value mean? Why was it not mock returned value? And the answer is because this is an asynchronous function. You'll go to create, you will see it returns this Prisma thingy, which is a Prisma promise, which if we keep going is a promise, which means since this is an asynchronous function, it will return a promise which will resolve. If you remember how to create a promise, how did we create a promise? Const p equal to new promise. Resolve, comma, reject. And eventually this promise would resolve. So what does mock resolved value means? It means that I know create is going to return a promise. The thing that the promise resolves to is what I'm mocking. I'm not mocking the value. If you would do a mock return value, then you would have to do something like this. New promise dot resolve, or no need for a new, I guess. Promise dot resolve. Promise do not. Or this requires like a Prisma promise and not promise basically. Like create requires you to create such a complex object, which is, you know, if you go here, it extends a Prisma promise, so it won't be as easy as doing this. But yes, Or maybe it is actually, maybe I'm missing something obvious here. Let's see. Yeah, it expects it to return a Prisma promise. You can get fancy, return a Prisma promise over here, or just rather than using mock return value, which you would use for a synchronous function, you can use mock resolved value for an asynchronous function. I can do the same for the upcoming test as well. Okay, here I want the ID to be 100. I want the ID to be 2, let's say, because this is the second request that we're sending. And this won't matter over here because the control will never reach the database call. If you look at this test, A is very big. And if A is very big, the control would stop right here. So it would never reach the database call. But if it did, then you would add a mock resolved value here as well. That is how you mock return values given a function. And why do you need it? You need it because a lot of times these return values are used, and hence you can't just mock out. You are still mocking out the thing, but you're giving it a dummy return value so that whoever is using the return value, which in this case is this thing right here, can actually get something in the ID key and request isn't undefined. That is what mocking return values means. Test pretty much covers the same thing. And then next up, we're going to understand about spies and how are they different from mocks. All right. You might think you have a very nice testing suite. You have a post endpoint, which does a bunch of checks, returns 422 if the thing is incorrect. You have caught this branch. If you go to the tests, you have a test that actually sends the wrong input and hence covers this branch. You've also added mocking logic over here. And hence if the control ever reaches here, you don't actually hit the database. And even if this returns a value that you are dependent on, you have mocked out that value as well, the mocked resolved value function. So you might think, okay, now I have a very strong testing suite. There can never be anything wrong here. And if there is ever anything wrong here, then my tests will fail. Let's try out a few things. Let's say some dumb developer comes and makes this something like this, makes a mistake, and the tests begin to fail. If we revert, then the tests succeed again. Let's say some dumb developer comes and sends the wrong status code. Then the tests begin to fail. Makes it correct. Tests begin to succeed. A dumb developer comes, does this. Tests begins to fail. Corrects the logic. Tests begin to succeed. So might seem like tests are doing the right thing. But one small thing. What if I do this? If by mistake, I start to store the wrong things in the database. Can you see that the tests are still succeeding? So can I say that my tests are a little flaky? Even though I'm sending wrong inputs to the database call, the tests are still succeeding. And what's the reason for this? That we have mocked out the database call. We are never testing the thing that we have sent it. Is it right? We were never testing the inputs to the mock. We have started to test the outputs a little bit. If you remember, we started to mock out the response from here and make sure that is what is returned to the front end. But we haven't yet tested, are we sending the right inputs to this function call? Or are we sending something wrong? This is something your tests should ideally test. When you're writing unit tests, you should mock out the database calls. You should not have any external services actually be called. But at the same time, you should test the inputs and whether or not you are sending the right inputs to a specific functions. This function can be mocked out, doesn't need to hit the database, but the inputs should be validated so that if there is a bug here, it does get caught during when you're writing the tests. So if I write, sum and multiply, right? What's the other enum? Oh, there you go. Sum or multiply here. If I change this to multiply, if this is the wrong input, the tests should fail. Question is how? Since we have mocked out this database call, how can we spy on this function call? What does spying mean? It means that even though this is a mocked function, I want to spy on it. I want to see, was this called? What inputs was this called with? Were the inputs this or something else? That is what spying on a function means. It's different from mocking a function. When you're mocking a function, you're simply saying this should be an empty function, should return undefined. If you mock the resolved value, then you say, okay, this should be an empty function, but should return this value. But you never spy on the function. You never check, was this function called? And were these the inputs that the function was called with? That is what spying lets you do. While mocks let you mock the functionality of a function, spies let you spy on a function call. Right now, we've only mocked out database calls. We've mocked out database calls, which means that even if I pass the wrong inputs to the create function, the tests would pass. If I flip A and B, the tests are still succeeding. How can we fix that? You can spy on Prisma client dot sum dot create. You can be like, hey, this specific mock I want to spy on by adding this line of code. Let's add this to one of our tests, maybe the first one right here. Prisma client dot request is the thing that we want to spy on. And then after the function has succeeded, we can check, hey, did Prisma client dot request dot how do you assert? Expect to have been called with? Yes. Expect Prisma client dot request dot create to have been called with. What are the inputs that we expect the create function to have been called with? Data. A should be 1, B should be 2, type should be sum, and answer should be 3. This is what the database call should have been called with. What are we saying? Expect Prisma client dot request dot create to have been called with these inputs. These are all constructs that VTest or Jest provide you. Given you have a spy on a function, in this case, we are spying on Prisma client dot request dot create. This is the syntax for it. You first have the top level object you want to spy on, and then you have the function, the actual function that you want to spy on. And lastly here, we are expecting that Prisma client dot request dot create has been called with A1, B2, type sum, and answer 3. If you look at it, tests are still succeeding. But if I flip the inputs by mistake, if a developer makes this mistake, tests begin to fail. What do the tests say? They say that this expect is failing now. Create has not been called with the right inputs, even though this was the expected input A1. The expected input to that function call has become A2. So if a developer makes a mistake and by mistake flips these, or makes this multiply, whatever errors could be in this function call, this mocked out function call, we are now catching by making sure we are spying on the function and ensuring it is called with the right inputs. That is what spying means. It is still failing. If I change this back to sum, you will see the tests begin to succeed. That is what spying lets you do. It lets you spy on a specific mocked function, and anytime that function is called, you can check whether or not it was called. You can also do things like to have been called once, because we know, okay, create should have been called once and not more than once. So that is one thing you can check. You can also check to have been called times 1, which means ensure it was called once. If I type 2 here, then the test will begin to fail because the create function was called only once. So that is how you create spies on functions, and you ensure they've been called once, twice, as many times as you want. You can also ensure they've been called with some certain inputs, which in this case is, A1, B2, type sum, answer 3. That is how you create spies, and that is why you need spies in a use case like this to check the inputs to a mocked function. Lastly, we need to understand how to integrate all of this to a CI/CD pipeline. How do I create a pipeline that maybe runs when I push my code over to GitHub, and anytime someone creates a pull request, the tests actually run and let the user know whether something is right or wrong. If you go to the repository for this week, you will notice the repository has a bunch of assignments / tests inside the assignments. For example, if you go to 5 Express VTest Prisma, you will see it has this very similar code to what we've written. It has a post request to /sum, which returns answer as well as ID. It also has a bunch of tests over here where we're spying on a function, we're ensuring it's called with the right inputs, so on and so forth. How do you make sure if someone creates a pull request? As you can see, I've created 2 pull requests here. One of them has a cross and one of them has a tick. How do you make sure if a developer makes a mistake? For example, here the developer flipped A and B, the thing that we were trying out locally right now. If I flip A and B, then the tests should fail. Wouldn't it be nice if whoever made this change, the maintainer doesn't have to look at the code. The maintainer can simply say, hey, the tests are failing. Can you check? Wouldn't this be nice? That is what a CI/CD pipeline lets you do. There is another pull request that I have created. This one, it says all checks have passed, because here I'm not making any change. I just removed an extra line of code. But in the other pull request, I indeed made a wrong change. I changed something that breaks our application, and thankfully it was caught by the tests itself. I don't have to pull the code locally and manually test it at all. That is something you should always do when you're writing tests. Otherwise, there's no real point of writing tests if you're just running them locally. You should have them integrated to your CI/CD pipelines. How do you create a CI/CD pipeline? We have done this in a class, but how do you create one for this specific use case? Pretty straightforward. You write the YAML for it, which looks something like this. Anytime there is a pull request on the main branch, if someone is trying to merge some code into the main branch, a build job should run, which should run on an Ubuntu latest machine. This should ideally be called test, but build is fine as well. And the steps that it needs to follow include, number 1, it needs to check out the code. You use the actions/checkout at the rate of v2 action to clone the code. If you don't understand this, go back to the CI/CD class. You set up Node.js version 20. You can also change the version using actions/setup-node. What is this? What is this? These are all actions that people have created. So you don't have to write all of this code yourself. You can also write this code yourself to clone, to set up Node.js. But thankfully people have written it. You simply use those actions over here. Lastly, install all the dependencies by running npm install and npx prisma generate. Notice I don't have to start a database because this isn't an integration test. I just need to run npm install and generate my Prisma client. And lastly, run the tests by doing npm run test I've done it in the 5 Express VTest Prisma repository or folder, because I have a bunch of folders here. Each one of them has their own tests. So I'm just running the tests of the last one. You can run it for all your modules if you want. You can create a global package.json where you have an npm run test that tests all 5 of these modules. We are just testing the 5 Express Prisma VTest folder by running npm run test there. If someone makes a good PR, the tests succeed. If they don't, the tests fail. You can track all of these actions in the actions section over here. This pipeline was created because a pull request 2 was opened by Harkirat. What have we written here? Anytime there is a pull request on main, the action should run. That is exactly what is happening. Pull request 2 opened by Harkirat, pull request 3 opened by Harkirat. So that is how actions are being created. And our code is being tested even before it merges. Even before, I have not yet merged this pull request. Even before that, I can see the checks have succeeded. This should be called test. I had written build over here, which is why you see build over here, but ideally this should be called test. That is how you add a CI/CD pipeline. Will look very similar for the code that I'm currently writing, only since I do have a 1easy folder here. So I will just have to replace the working directory here with 1-easy. That's how you add a CI/CD pipeline. Hopefully this is fairly straightforward. Try to add this in your own code, push it to your GitHub, create a pull request, create an errorless pull request, create a write pull request, and make sure it works. Lastly, I'm going to take you through Difference between unit tests, integration tests, and end-to-end tests. We have covered unit tests until now. We might be covering end-to-end tests as well, because there is not the best unit test and integration test support in Next.js. So we might have to write end-to-end tests for all the repositories that we have. Let me take you through all three of these and the definition of them. We'll try to cover end-to-end tests in an offline video later on, where I'll probably be writing them for one of the repositories that we have. Unit tests, the thing that we discussed right now. If you mock out all the external services, only worry about what the current function is doing by mocking out all the external services like database calls, Kafka, things like these, then that's called a unit test. Integration tests, if you don't mock out these services, but actually start them locally, then it's called an integration test. If we had a backend where we were not writing any mocking logic, we actually started a database anytime I ran npm run test, is what would be called a integration tests. Now, whoever is running npm run test, we need to start a database locally on their machine, which is why this gets a little complicated. Usually, when you write integration tests, you expect the user to have Docker on their machine. And whenever you run npm run test, you first start a database Docker container. You then update their .env file or this env variable to point to that Docker container. And then you run all of the tests. And when this succeeds, you also tear down the Docker container. When I say tear down, I don't mean tear down, I mean tear it down. You stop the Docker container as well, so that whenever a user on their machine runs npm run test, they're able to test the whole thing. That is what integration tests mean. Why is this problematic? Because the number of resources you are using is a lot. You need Docker to start, then inside the Docker you need Postgres to start, Kafka to start, and then only can you run the tests. It is good because you don't have to mock anything, you don't have to spy on anything. You can literally have a full backend running and being tested. But the downside is you have to start Postgres locally. So whoever is the developer needs to have Docker. That's just become common pattern now to start integration tests to create Docker containers. If your developer doesn't have Docker on their machine, they will not be able to do a npm run test. Lastly, end-to-end tests are slightly easier. If you have a full stack application, which means a browser, like a front end and a back end, and you actually open a browser and test things, then it's called an end-to-end test. Cypress is one famous framework that lets you do it. As you can see, it says test, automate, accelerate. You write your tests like this. Okay, hey, oh, oopsie daisy. As you can see, the website actually opened and a button was actually clicked and sign in was actually done. These are like very nice automated tests which open a browser and actually log the user in, do all these things. And if you look at the test, it looked something like, where did it go? There you go. The test looked something like this. Okay, describe, I am testing authentication. This is the test case. User should be able to log in. And then Cypress comes into the picture. You see, I want to visit the landing page. I want to click on the login button. Sci.get button means get the first button that you see that contains the word login inside, and then click on it. Get the two input fields and put some dummy data in there, and then click on the button, and then make sure logout button becomes invisible after the user logs in. This is an end-to-end test. It tests. It literally opens up a browser and clicks on a login button that you see here, puts the email, puts the password, clicks on sign in, and ensures that the logout button is visible. That is when the test succeeds. If you look at it, what was the final assert that we were doing? Sci.contains this thing should be visible. Syntax is always weird. All testing libraries have a very verbose syntax, almost like you're reading a sentence in English. Sci.contains button logout should be visible. So, this is something we get comfortable with, but thankfully, I don't think this is a downside. I think this is an upside. Okay, whenever you're writing tests, you write them like this. Okay, expect something to have been called with this data, or expect something to be this thing. So this is like very common pattern. Cypress is one framework that lets you do it. Playwright is another framework that lets you do the same thing. Playwright framework. Playwright enables reliable end-to-end testing for modern web apps. As you can see, it supports these 4 browsers, which means one of these browsers would open up and the test would actually run. That is what a end-to-end test is. This is something we should probably add for the mono repos that we have. CMS, daily code should all have end-to-end tests that actually start a browser, log in a user, make sure the tracks are visible, make sure the next button does what it's supposed to do, things like these. So that is all for testing. We'll probably have an offline video on end-to-end testing later on. With that, let's end it. I'll see you guys in the next one. Bye bye.